Okay, I guess that part of the video cut off. I was going to go down here and see about what I had these configured at. So, if you look at the chart, I've got the switches set on, I believe 12,000. Let's take a close look at it. Because I watched other people configure these drives and it seems like they go around 4,000 pulses, and I'm just using a low resource laptop, but I am using a generic smooth stepper drive or control board. Yeah, so I'm configured at looks like 12,800 pulses per revolution, or per unit. That is actually pulses per revolution, so that's 12,800 pulses per revolution. It's 5.08 turns for 1 linear inch, because the ball screws are metric. They're 5 millimeters per revolution. Okay, so the switches are set to 12,800, and that means that 5 is on, or actually 5 is off, 5's on, 6 is off, 7's off. And it looks like 8 is on, right? Yeah. Okay. Enough of that boring stuff. So, and if you look at the switches, that's exactly how they're configured. Incidentally, on is marked right there. So, you're looking at 5, 6, 7, and 8. 5 is on, 6 is off, 7 is off, 8 is on. So that's 12,800 pulses per revolution. And then you multiply that times 5.08. And that's how many pulses you have per driver per 1 inch unit. So that's some pretty heavy duty microstepping for a little laptop. This is just a little bitty HP laptop. I did put Windows Professional on it, but the key to the whole thing here is this control board, which essentially gives you 3 parallel ports via USB. So like my limit switches are connected to port 3, so it'd be like parallel port 3 and input 3. And then I also have my limits on the over travel set on the same one, so they're basically in parallel with one another. But they do work, so you can home it, you can home the system and drive it home. And then over here I've got I just have a simple program in here right now that is, I believe it's called Max Travel. So my Max Travel just works all 3 axes along the full distance of the overall footprint or size of the table, which is incidentally right around 23.75 by 15.5 by 4-inch Z. So let me go ahead and fire that up so you can see. And right down here, you see where my cursor's moving. This is where your feed rate is at, or set for the program. But this program I just do rapid, so whatever rapid's at, that is where it goes. So if we're at 100% jog, and I've got the motors configured for around 70 inches a minute, that's what they're going to run. Then on the diagonal they'll run about 90 inches, and you'll see that in just a minute. So I'm going to regen the toolpath, and you'll notice machine coordinates and work coordinates. We're using the work coordinates. So if you look at the code, first thing it does is picks the z-axis up to 1.5, then it moves the x to 15, then it moves the z down to material top 0, or where it thinks material top 0 is. So let's just hit the cycle start and watch it. So we're moving the X, and then when it gets to that side, it's just going to come up and just kiss that limit switch right there. Not even quite push it in, just kind of touch up against it. And I've got this program wrote. Now you're moving the Y and the X together back to the other end of the router table. When I put the plywood down so that I can actually put a spoiler material on top of this when I'm cutting, so I don't actually cut into this plywood here, but I can screw the spoiler down to the plywood and use that one over and over. So now it's going to move over there and just kiss that limit switch again, but not push it in. It just goes right up to it. And now it's coming back towards us, or towards this end of the table, which is actually the home end of the table. So I have it home all the way down to the end closest to the computer laptop. And you'll see it move the X across. And that's actually moving at 76.5 inches right now. And then you'll see it exercise the Z up and down real fast. Maybe not real fast, but pretty fast for stepper motors. And then on the diagonal, the X and the Y moving together is 91 inches a minute. So not too bad for open loop stepper motors. And this program runs for about 30 minutes, kind of running the same sequence of axis motion. It's got a couple dwells in there, like right now it just sets for 2 seconds, then moves the X and run the Z up and down. There again, it's going to go right up to that limit switch. So I'm going to push it in. It's just touching it right there. And it doesn't seem to miss a single step. So when you micro-step with the right drivers, it looks like you can push the stepper motors pretty fast. But if you want real fast, you've got to go to closed loop servos. But this is not bad. I mean, it's economical and it performs pretty well. And there you go, 91 inches a minute. All the max travel. Moving to the other end of the table. And it's 24 inches down to the other end within a few seconds. I mean, it's not too shabby at all. Still a lot of work to do though. I need to get all that stuff into an enclosure. Probably going to get some better cables for it. I just have it kind of wired up right now with good connections, but just not real state of the art. I'd like to see some Canon plugs on here and things like that. But the performance of the drives, and I don't know if you can see underneath, I've got two separate power supplies. One is for the control board with the USB printer cable plugged into it, and the larger power supply is for providing power to each one of the drives. And that, incidentally, that board can control 4 axes, so you could add, I kind of left a little space in here where I can add another drive and either dual drive the Y axis, or we can put a 4th axis on there and do some polar coordinating along the X or the Y. You see it dwell for 2 seconds, then it'll move the X across. Try to get back here where you can see the whole thing. Move the Z, and then heading back to us. That plywood picks up every little sound. I can hear the slight misalignment in the motor couplings, and you can kind of hear the plastic. This is just some cheap Harbor Freight wire cable, but the cables are actually Aegis flex chains. The cable's real high quality. It's also shielded, so the limit switch connections are all shielded all the way back to the controller here. And I did not make the cables any longer than I needed to. I think it's always best. So just really want some good heat shrink, solid soldered connections if possible, and really just make up all the other connections with without having a bunch of whiskers hanging out, and make sure they're stripped off so that you have the full number of strands made up in the terminal blocks, and you get optimum performance. But for sure, Cannon plugs and a good enclosure for the control panel would be next. I've been working on this for quite some time now, and it's not that I've been working on it every day, it's that it sits around and then I pick it back up one night and try and go again. And I do have a couple of control panels and things I want to cut out on this, but I've got to get my Cool Mist connected up to it so that I can cut aluminum panels. So I still look forward to doing that, but more work to do yet, unfortunately. But we will get there. Thanks for watching.